Welcome. In this video, we will take a look at finding the derivative of a function at a given point using the definition. So we want to find the derivative of f of x equals 4x plus 7 at the point x equals 3. And again, we're going to use the definition, the limit definition at x equals a. So that's the derivative f prime of a is equal to the limit as h goes to 0 of f of a plus h minus f of a over h. So here we know that our value we want to evaluate here is 3. So a, in our case, is the value 3. So we can rewrite this as the limit as h goes to 0 of f of 3 plus h minus f of 3 over h. So let's take a look at this limit and try to break down what this is representing. F of 3 plus h, that's the f function evaluated at the point 3 plus h. So let's write that down. We have the limit as h goes to 0 of f of 3 plus h is going to be the function 4, and then we're going to input 3 plus h plus 7, that is f of 3 plus h, subtract the functional value at 3. If we do the functional value here on the side, that would be f of 3 equals 4 times 3 plus 7. In total there, looks like we'll have 19. So we're going to subtract 19 and then divide everything by h. Okay, so let's continue to manipulate our limit. We can distribute our 4 into the limit. So we have the limit as h goes to 0 of 12 plus 4h plus 7 minus 19 all over h. Now, taking a look at our numerator here, I think we can add some constants together. We'll have 12 plus 7 is 19, minus 19. Each of these, I think, is just going to go to 0 when I add. So I can rewrite my limit one more time. This is the limit as h goes to 0 of 4h divided by h. But a nice thing happens here. We can just cancel out the values h in the numerator and the denominator. And when we cancel, this limit is left to the limit as h approaches 0 of 4, which is a constant. And so we know that if a limit is in a constant, it's just going to be 4, that constant. Because a constant, there's no h's left, so the limit is not dependent there on h anymore. Now, what did we just say by this result? This says that the derivative f prime of 3 is equal to 4, which means the slope, or the instantaneous rate of change at the point x equals 3 is equal to 4. Well, this should not be surprising to us because what did we start with? We started with a linear function, 4x plus 7. And we know that the slope at every point of that linear function is that m value in our equation, that would be 4. So no matter what point we choose, the derivative for the f function here should be 4. But we just found that using the definition of our derivative. So in fact, any point on this function f, we would get a derivative of 4. So hope this helps with working with the derivative at a single point. Look forward to seeing you in the next video.